So thanks for bearing with me. We're going to start. We have the majority of our participants with us. So just one last time, because I practiced this a bunch of times. Welcome to our data collection and retail workshop. This is going to be a technical talk and hands-on practice. I am Nadav Reuter. I'm a data collection expert. And today, let me just introduce you to a little bit about the different people who are going to be attending with you today. 171 registered attendees from 144 different companies from 14 different countries. You guys are sitting with software engineers, developers, data scientists, architects, team leaders, and product managers. So this kind of gives you an idea of the types of people who are with you today. And then also I thought this would be interesting for you guys. When you guys first registered, we asked you, what level of crawling skills you had. And the responses were quite varied, even though 56% were really on a beginner crawling level. 20% of our audience today is currently using automated crawling. 15% is has in-depth knowledge about crawling and data crawling skills, and the rest 9% is doing manual crawling now. So we have a really varied audience, and actually we have a great agenda for you guys today, and that's going to really give you some insights on how to begin your data crawling and continue your data crawling and develop your data crawling skills. So let's take a quick look at our agenda for today. We're going to start you guys off, first off, with the strategic role of data collection and retail, and that's going to be given over to us by Omri Orgad, who's our managing director in North America. After that, we're going to move on over to data collection infrastructure, and that's going to be given to us by our panelist, Aviv Bazinski, who's a product manager. The third thing we're going to talk about, and there was a lot of interest in this prior to the webinar, is active and passive fingerprinting. And Josh Vanderwillig, who's a product manager of ours in Canada, he's going to be speaking a little bit about that. And finally, we're going to finish off with Gal El Al, who's the head of support here at Luminati, and he's going to talk about how to streamline your data collection. Now, I just want to talk a little bit about questions and one-on-one guidance. So if you look at your screen at the bottom, you should have a symbol of a hand. So you can raise your hand at any time. I'm going to see that, and then there's going to be intervals between panelists, and we're going to allow for questions. In terms of actual written questions that you guys have, try to refrain from doing that in the chat. Really just write them in the Q&A. We're going to try to get to everyone. And we're going to try to choose the questions that are most interesting to our audience. Now, if for some reason we don't get to your question, please don't be discouraged. At the end, all of you, we're going to share a live link for you guys to set up a one-on-one session with our data collection experts. And we're going to also send that in a follow-up email. So if your question was not answered and you want help with your data collection project, we'd be happy to help you. So without further ado, I want to give the microphone to Omri Orgad, who's our Managing Director of North America. Omri?
Hi, thank you.
Sure thing.
Second, screen. There you go. First of all, a bit about me and my team, more importantly. My name is Omri, and I'm actually the first non-dev employee at Luminati, and I've been around here for about 6 years. And I lead the US team. We started to build up the US team last year. And you can find today in the US team product managers and support managers, directors, and so on and so forth. And we're really proud of this effort. But enough about me and the team. So first of all, I will discuss the strategic role of data collection in retail. And the first reason, the first topic is to explain actually why. Why is it important? The network or the web as it's structured today, and the way that it's served to users, it's not flat and it's not transparent. What does it mean that it's not flat? In order to serve personalized data, the websites identify each user by multiple factors. One of them could be the IP. The second could be maybe to tag them according to geo, maybe country or city. And it could be also by device, or you might call it user agent, or in cookies, which might you call browsing history. So each user is getting a very personalized information. In order to generate insights for that information, you actually need to see the web the same way that users are seeing it. So in order to really understand what's going on and what is the competitive landscape, you need to see each data item as it's served to the user. Some websites even serve bot management solutions, and that leads me to the second point. In many cases, we see that the web is not only not flat for actually good reasons or good for the user's reasons, but harder for the competitive intelligence performance. In many cases, we see that websites are blocking or misleading or just giving you the vanilla pricing if you come from a proxy server. So that creates a very difficult picture or difficult image to analyze if you're not approaching it correctly. Here we see another example of dynamic pricing. We see three players: Sears, Best Buy, and Amazon. Sears may be more predominant, I would say, brick and mortar. Best Buy is kind of an omni-channel player, and Amazon, of course, is a very pure online player in terms of how they approach the web or how they approach pricing. So in this case, we see that Amazon is changing the pricing multiple times a day, Best Buy maybe a couple of times a day, and Sears is not changing the price. Now, this creates another layer of difficulty on top of the IP or the geo, the user agent or the device, the cookies or the browsing history. Every time point actually looks different. So in one case, the users are seeing it differently. So on the other hand, the corporate will want to also see it the same way that users are seeing it. So in order to facilitate a strategy that will actually make sense, you first need to understand how the landscape looks like and how it behaves. And the first thing that we understand, it's not flat and it's not transparent. So how we help to address that challenge? First of all, Luminati is the owner or the developer of patent technology that serves. We started out 6 years ago with residential IPs. Today we have about 72 million IPs. That's a big number. It could be even irrelevant. The important thing is it's a robust network that allows you to see the web the same way that the users are seeing it. Not only we allow you to see it the same way that users are seeing it, we do it in a compliant way, and that compliant way is what, or transparent way, it's what allows Luminati to have, I would say, enterprise level customers and to maintain the robust network for so long. So businesses are using Luminati, of course, to overcome the blocking. I would say the core value of Luminati is to allow enterprise or retail chains or any other Luminati customer to see the web the same way that users are seeing it in a mass scale. So once you use Luminati, of course, you're able to see what the users are seeing it. Few numbers, Luminati routes about 9 petabytes of data every month. This is just another kind of indication of the robust activity. We have about 10,000 customers, 40% it's e-commerce. I would say another number for the US viewers is that we see that about half of the business is the US and about half of it are, I would say, enterprise level customers. So the way that Luminati solution is layered, and I think this is, we kind of indicate how the market is layered. On one side, you see the infrastructure. We have the proxy network. That's a very kind of basic hook up to the infrastructure and start to route traffic. In the middle layer, or I would say the application layer, are unblocker and the proxy manager. The unblocker is the black box that guarantees that you have 100% success rate. So basically you send the URL and you get a response, and then you don't have to handle the retries, the signature that we'll talk about and all that mechanisms. Or you have the proxy manager, which is the open source code that basically you establish a router and you start to route traffic and establish rules. We'll go on about it, but the important thing is this is an application layer that you assume most of the responsibility, but Luminati helps you along the way with a lot of the development. I would say we kind of integrate lesson learned from our customer. And our latest product is our data collector. Basically point us in the right direction and we'll structure the data. You can do it as a self-serve and literally, upload the template and start to click and get the data. You control the schedule and so on and so forth. I won't go into the details, but it's a very amazing product that works great. Some changes that we see in COVID, I think what happened in COVID-19 was very interesting in terms of data came to the forefront. One of the example is actually, I saw a post lately by Neiman Marcus CDO. I don't know if that exists before COVID, but basically what it says that the reliance on data, the reliance on available data helped them kind of climb out of the troubles that they had. And today they are on a new road. Of course, we see a lot of increase in e-commerce, and we've seen more people buying online, and we see more businesses scrambling to sell online. And part of it is to actually understand the landscape. And not only that happened, a lot of the data that was available in the past, today it's not available. For example, satellite images of parking lots. It's a data set that in the past was very interesting. Today, I don't know how much it's, if at all, it's interesting in retail. And you see different data sets that are coming coming to their own, I would say. Some use cases. When we say retail, I think in the enterprise level or in any level, it's a mixture of a lot of different use cases. First time, I think the first one and the basic one is, of course, real-time price intelligence. When you say price intelligence, it could be anything from competitive intelligence to learn the real price of a product, the way it changes over the time. The second thing is the inventory level, how much inventory is sold, the changes of that, and so on and so forth. And it's also a brand protection activity as well. So you might monitor a shoe price for many different reasons. One is maybe to maintain an SLA. The other one is to see what my competitor is doing. But still, you take a look at the price. Another use case, it's SEO. It could be, where am I ranked in an e-commerce website, where I'm ranked in Google, how is my product described, how my competitor is describing my product, and so on and so forth. You can also learn a lot about the reviews, the different reviews for different products. You can learn actually, you can learn a lot from that, obviously. Some use cases, a large retail chain that targets multiple websites. I think here it's the use case. When you're a retail chain, it really depends what is your strategy here. Are you selling through directly? You have your own website? Are you selling on a platform? So it really changes the way that you structure the data collection. For example, it might affect the frequency because you have a decision not to change a price more than once a day, or you're changing a few times a day, what you're allowed to do on the platform and what not, and so on. So basically, the way that you are behaving strategically affects the way that you collect the data. Another interesting is actually monitoring your website for flash sales. And this is basically kind of two use cases intertwined. One is monitoring if there is a flash sale, when is the product released, and so on. And the second thing is to collect data when the product is released. It creates different strategies. I discussed earlier the way that the options, when you have the infrastructure level, you have the application level, and you have the data collection activity that you can go through. And the decision on how to go about data collection, of course, is affected by the complexity level of the data that you need, the amount of targets that you want to collect, or the way you want to go about it, how deep you want to go, so to speak. But it also how the company is structured. So for example, if I'm a startup and I don't have a lot of firepower in terms of development efforts, and I focus on data collection, I might even devaluate my startup by not focusing on my core product. If I'm an enterprise and I have a data collection activity running, maybe it's smarter to buy a data set than start to structure data sets with a proxy. So I think it's a combination of the strategy that you build here. It's a combination between who am I as a company, what is my general view on developing in-house, what's my I would say availability of dev efforts and their core competency, and what is the market around me, or how difficult it is to collect the data, how crucial is the data, what is the frequency, and so on and so forth. So it's really important kind of to understand, your competency within it, and also the surrounding in terms of how difficult it is, the amount of data that you need, what are the targets that I'm looking at, and so on and so forth. That's it. I appreciate your time, and I hope you'll learn in our in the next hour or so. And if you have any question, I would love to take them.
Great, thanks, Omri. I don't see that we have any questions so far, but don't worry, we'll have multiple intervals for people to ask questions. I'm sure people will send those in. And now we're going to move over to Aviv Bazinski, who's our product manager, and he's going to talk a little bit about data collection infrastructure and bot detection techniques. Aviv, the microphone is yours.
So, hey everyone, and thanks for taking the time to attend this workshop. So my name is Aviv, I'm product manager in Luminati. I manage two of our self-serve proxy networks, the data center network and the static residential network. And I also manage two of our automated unblocking products, the data unblocker and the SERP, the search engine results page product. So any questions about that, regardless of this workshop, afterwards, this is my email over here. You can contact me directly, don't hesitate. So generally, we're going to talk about a few things. We're going to talk about what makes a successful data collection operation. And then we're going to discuss a little bit into detail the different layers of a data collection operation, such as the proxy infrastructure in the background. How do you manage your proxies? And later on, Josh will get to the more sophisticated techniques and fingerprinting and so on. So let's dive right to it. So basically, the way we see it, there are four main elements to have a data collection operation being successful. We have speed, scale, success rate, and accuracy, and each and every one of them has different elements to it that we need to take into account. So let's start with speed. And first, I'll start by kind of defining what I mean here. So when I make a request to get a piece of information, I go through some infrastructure, my own infrastructure, then through my vendor's infrastructure. For example, Luminati's grid or infrastructure, servers, and so on. I get to the target site, the response comes back, and then all that round trip, as we call it, it took a certain amount of time. If it takes a long time or a short time, that makes a difference. It can make a difference in certain scenarios. So one very intuitive example would be real-time data collection. So that could be because my product is using real-time data collection in the background, or maybe the data itself is the product. For example, websites where you compare prices or look for the cheapest ticket and so on. And the second thing is you want to maximize the value of your existing resources. So if you need, for example, to collect a certain amount of data every day, if the infrastructure is built in a way that the round trip is very long, that means it will take you more time to collect the same amount of data. If it's within the boundaries of time that are okay, then that's fine, but maybe you need to collect some amount of information within a few hours every day, but your infrastructure is taking too long and you're not making that timeline. So that's something that you want to also take into account. And the last bullet here is just to say that we've made a lot of improvements on our side of the infrastructure to make sure that there's different processes happening automatically and making sure that the round trip is as short as possible and the requests come back as fast as possible. I'll give a quick example here, which I mentioned a few words earlier. So a great example for where round trip time is critical is for different types of real-time service. So if, for example, I'm looking for a flight ticket and I'm going to click the button, search for some flight ticket, and then if it's going to take 10 seconds to get a response, there's probably high chances that I'm going to buy that ticket. But if, for example, it took 5 minutes to get a response, there's most chances that by the time the response got there, I've already went to the competitor's website and bought the ticket over there. So it's very important. And this is only about speed. The second part is scale. So you want to make sure that all sides of your data collection operation are fit for the different times of the year or of the week or whatever it is with seasonality. And maybe you have some routine levels of traffic, but then you have usage spikes on holidays or once a week or whenever. You just need to make sure that the infrastructure you're going through by your provider is able to support that, and also your own infrastructure is able to support these usage spikes. The second part about scale is that, and we'll discuss this into more detail later, but when you scale your data collection operation, you might be focused on not being blocked, but something else that you need to take into account is that maybe you will not be blocked, but the target sites you're going for are identifying this increase in scale and starting to serve you false information. So keeping the data quality at scale is also very, very important. And just generally making sure there's no bottlenecks along the process. A great example would be Christmas season peak. Probably many retails companies have a lot more usage during Christmas time, selling different products, and obviously making much more requests, much more traffic through the data collection operation. So you want to make sure that your system is fit for these usage spikes. Otherwise, you could end up with, one of these stories about a website that stopped responding, or due to too much demand and so on. So you want to make sure that doesn't happen. The third part is success rate. There's a few parts about success rate, although it sounds very straightforward. The first one is getting all the data you need. So managing to, but putting aside the actual success rate, having enough success to get the information that you need. But then there's the second part, and I wrote here, build versus debug. And that relates to something that Omri mentioned earlier. As a company, that your core product is not the data itself, but that just serves you in most cases, then you want to make sure that you're not spending too much time and resources on actually getting the data. And if you have a good infrastructure or a good product that you're using to gather this information, then that frees your time and resources to actually manage on building your own products and features and so on, and not on getting the data that will enable doing all these things. The third bullet I put here is keeping effective price, and that is because in many cases, the pricing model is where you pay for traffic, and then the higher the success rate is, the less you pay for the same data. So a great example would be if I'm getting a 50% success rate, that means I'm actually paying 2 times more for the same data versus if it was 100% success rate. And the last point would be accuracy. And I've mentioned this earlier when I talked about scale. So it's not enough to get some data or some successful response. You actually want to make sure that you're being served with the correct information. There's different ways to do that. On your one-on-one sessions, you can discuss it into more detail, but generally you want to make sure there's no anomalies, that that numbers make sense, there's no missing parts in the response you're getting and so on. And you want to have processes to periodically or every time make sure that the data is true data, and have some verification system. A good example for when that matters is when you're collecting competitive pricing data, like the slide that Omri showed earlier, where different kind of e-commerce companies are constantly changing their pricing. So if I'm getting served with false information, that could dramatically affect my revenues as a company or my sales if I'm giving out the wrong prices. Okay, so we're done with the main elements and having a successful data collection operation. And now let's talk a little bit about the different layers of a data collection operation, and we'll talk about some of them later on into more detail. So what we have here at the bottom is the IP infrastructure. And basically, Luminati offers several proxy networks, which I'll talk about soon. And these proxy networks are serving both as self-serve proxy products, but also they are the basis, or they are the infrastructure behind some of the automated unblocking or data collection products that we offer. And it's very important to have a robust and diversified IP infrastructure for different reasons that I'll discuss in a few slides. Now, going through some very robust and good grid is not enough. You need to have a good way to manage your proxies. You might have different projects going on in parallel, different proxies, different ports, and so on. Maybe some of them need different rules, different targeting. They need to be able to manage that in one place. And we've developed a proxy manager for that, which I'll also discuss. And then on top of that, there's the more sophisticated part, which Josh, product manager in Luminati as well, will discuss after me. Different parts where you need to manage fingerprinting, cookies, headers, and making sure that you're not getting blocked with the tougher target sites. Okay, so let's dig a bit into the proxy infrastructure, how does it work, why does it matter, and so on. So I'll start by saying that there are different types of IPs, and traditionally, to make it very simple, there are two main types of IPs. One of them is data center IPs, which are traditionally used for servers, and the second type is residential IPs, which are used for homeowners or real people. Then later on, we have the mobile that join as well, but also representing a real person. Both types are legitimate and have their own natural ways of using them. I don't want you to get the notion that data center will be blocked and residential will not. It really depends how you work with it. For example, when Google indexes the internet, it goes through it accesses website through servers, and of course the websites don't want to block that because they want to be appearing in the Google search engine, so they're not going to block it, although it's a data center IP. On the other hand, I can also be blocked from using a residential IP if I'm not using it properly. So it's just important to understand the pros and cons. So let's have a quick brief of the four types of proxy networks, or four types of IPs that we have. So the first one is data center. We have a network of about 750,000 data center IPs, around 95 or 92 countries. The most big advantage and the most clear advantage of the data center network is that it's very cost effective. It's just basically cheaper. If you know how to use it properly, it can help you reduce costs. The downside of using the data center network is that it's just smaller than the next network that I'll be talking about, and that can have implications. And for some use cases, it's important to have a very, very large proxy network. So let's go straight to the residential proxy network, which was the first proxy network Luminati came to the market with, pioneering the peer-to-peer residential network. It has around 72 million IPs on a monthly basis, so much, much bigger than the data center network, based on our peer-to-peer technology. Basically, it has global coverage of pretty much any country and city in the world, also a large variety of ASNs, carriers, and so on. So any large-scale proxy operation or ones that need a very wide global coverage, residential network is a great choice. And also, since the residential IPs, and these are real user IPs, are being perceived by the websites as real user IPs, the websites will be much more forgiving. These IPs are much, much harder to block. So generally, great network to use. We also have the mobile network, which was added later on. It's the same concept. These are real mobile user IPs, and we have around 7 million IPs on a monthly basis. If you need to see the internet from the eyes of an actual mobile user, for example, maybe for ad verification or something of that sort, then that's a great option. And then the last network that we added to our system is the static residential network. And basically, the static residential network is real residential IPs. They are listed by the different websites as a residential IP, but they are not actually assigned to any homeowner. So they are hosted on our side on an architecture which is more similar to a data center architecture. That means they don't rotate. This is their main advantage. For some use cases, it's very important that the IPs do not rotate. You can keep them for as long as you need. Downside for this network, similar to the data center network, is that it's just smaller. It is residential, but it's much, much smaller. It has around 150,000 IPs for the static residential network versus 72 million. So it's completely different size. So these are the IP types. And what's important to understand about the IP type of the infrastructure you're going through is that the IP type is an IP property. It means that's just a property of the IP. It's a given. That's not something that you can emulate in a different way. You can't take a data center IP and add some header and make it appear as a residential IP. It's either a data center or residential or mobile. It is what it is. The second part is scale. So we have different networks, different sizes, and for some proxy operations, for some data collection operations, there's no need for too many IPs. For others, there's a need to gather huge amounts of data in a short amount of time. And in this example, the residential network would allow you to pretty much make any number of concurrent connections as you need. And that, again, is a network property. So if you need a very, very large network, then there's no other way to get that other than going through a network which is actually very, very large. That's something that you need to take into account. If you're going through a network that is too small, you'll probably start getting blocked pretty quickly, or the quality of data will be low, and so on. And then the third part is global coverage. So every IP address is listed in different geolocation databases, and the websites you go to, they check where is this IP coming from, what countries is listed under, and you need to make sure that the proxy infrastructure you're going through is holding the global coverage that you need. For example, the residential network has really pretty much any country and city in the world. I've not encountered any case where a customer needed some location and we didn't have it for the residential network. So global coverage is also a property of the IP and the network, and you want to make sure you actually have the appropriate proxy infrastructure for your own needs. I'll give a quick example here. So let's compare going through a proxy network versus using one server in the United States for collecting data. So if I would go and try collecting all the data I need through one server in the United States, and let's assume that it's powerful enough to handle the traffic, then there are a few things that I would notice. One, my server IP is listed as a data center IP. That means the target sites are going to be less forgiving. And since I'm making all these requests through a single IP, I'm probably going to get blocked pretty quickly. And then also my data center IP and that server it's in the US, so it's listed as a US IP. That means all the data I'm getting is data the way it's seen by United States user. And if I need other countries, then I won't be getting that. Versus using a proxy network, so you can have the right IP type and you have scale. You also have the right global coverage. Okay, so let's move.
Now, Aviv, I'm sorry to interrupt you. Just if you could go back one slide, because we have a question that we want to answer live. I apologize.
Sure.
So someone's asking here. We don't have the name, unfortunately. It's an anonymous attendee, and he or she is asking, what makes an IP residential? If you could just reiterate that for them, I would appreciate it.
Sure, and I'll also show that into more detail later, but basically every IP in the internet is listed with a certain number of characters. Among them are what is the geolocation and also what is the usage type. So a residential IP is an IP that is being used and used for homeowners by different internet service providers. And when an internet service provider gets new IPs, it basically makes some formal request to these geolocation database, such as Maxmind or IP2Location or Google, specifically for this case, mainly IP2Location. And they basically say, hey, we've got this new batch of IPs that we need to use for internet service. Please list them as residential IPs. And then IP2Location or whatever geolocation database it is will agree and list them as residential IPs. And then basically, if any one of you goes now with their home connection to IP2Location, you can look for a parameter called usage type, and you will see that it's called the ISP, fixed line ISP. And basically that means it's a residential IP. This IP belongs to a homeowner. So I hope that answered the question.
Now, Aviv, just one more quick question, please. So Amar Gandhi is asking, what is the best type of server to use and the most secure? Is it mobile proxies? Maybe we'll just answer that one more.
There's really not one answer to this question. Basically, I've listed the pros and cons of each one of the networks. If you have a very easy target site and you don't need a huge number of IPs, then you could probably use the data center network, and that would give you the results you need. If you have websites that are more sophisticated or harder to unblock, you might want to use the residential network. Also, if you need a very, very large amount of requests being sent in parallel, then you want to use the residential network. In terms of security and so on, they're all the same. Anything that goes through our network is completely secure, and that goes without saying. Yeah, so I hope that answers the question.
Great, thank you.
Okay, so let's go to the next slide. So this relates a bit to what I answered just now. So when you go to a target site, there are different things and different ways target sites checks in order to identify things about who you are. And I'm talking about the IP address. And there's different restrictions that the websites might apply, or different changes. So basically, the main ones would be IP-based classifications, and then there's geo-based classifications and rate limiting. So let's talk a little bit about each and every one of them. Here's the usage type that I discussed earlier. So when I go to a website, the website checks my IP through one of the main geolocation databases, such as MaxMind, IP2Location, Google, IP Info, DBIP. There's many of them. And then one of the things it checks is what is the usage type, and that is to determine, is this a server, or is this that could be collecting information, or is this a homeowner, a human user? And in that case, it's probably a potential buyer, and I don't want to block him. Is this a mobile user? And then maybe I want to present things in a different way. Basically, it wants to understand what type of user you are. So if you understand that there's a certain usage type that you need to use, then you want to make sure you're going through the correct network. And by the way, I was talking about the static residential network. So basically, the static residential network has a usage type of ISP, fixed line ISP, meaning it's identically the same as a real residential IP, but it's not actually assigned to a homeowner. That's the only difference. Okay, the second type of classifications, or here actually restrictions, is geo-based. And that means when I go to a website, it checks in the same geolocation databases that I've mentioned earlier, where is this IP coming from? Or better said, not where it's coming from, but what countries is it listed under? So if I see it's a United States IP, or Great Britain, or whatever it is, I might serve different content, or I might show the website in a different language. There could be different pricing, or there may be even different pricing elements, like shipping would be for free for one country, or would have a certain cost for other country. Many, many things that can change from different geolocations. So that's really important to be aware of. If I want to check, for example, what is the cheapest flight, I might want to check that from different geolocations, and then I can give different results to my own users depending on the different geolocations. There's also some services and websites that might block you if you're coming from the wrong geolocation. Maybe some locations are open and others are blocked. That's something you want to take into account as well. That's, for example, is very popular with streaming services. And then, of course, there's different ad campaigns going on through the internet. And then if, for example, I want to make some ad verification project, I want to make sure that the ads are being presented in the right places, in the right format, right language, and so on. If I want to check ad campaign running in India, for example, but I'm going to exit from IPs coming from the United States, I'm just going to see the campaign in the United States. I'm not going to see that campaign running in India. So it's very important that you run through the right geolocation. And then the last part about that is overcoming rate limitations. Rate limiting is not a new concept. It originally developed mainly to prevent DDoS attacks or denial of service, distributed denial of service attacks. So basically, the website is saying you can't make more than a certain number of requests in a certain time frame. For example, no more than 100 requests per minute, per IP, of course. And that's something that you really want to take into account, because when you make requests through a proxy infrastructure, if it's a self-serve, I mean, because if it's automated unblocking, they will do that for you. But if it's a self-serve proxy network, you want to make sure that you're rotating the IPs properly and using them in a smart way, so you're not actually getting blocked. And what these websites actually do, in simple words, is that if an IP is making too many requests, then it's going to be blocked. But not only that, if several other IPs are being blocked and the website identifies that they are part of the same range of IPs, it might actually just block the entire range for some time, and then that can be more disturbing for your data collection operation. Just to show you what that would look like. So if I'll give an example, we have a /24, that's the name of a range that includes a group of 256 IPs. And then I could make requests to some website and have, I don't know, 5 IPs reaching the rate limit and being blocked. And then the website could look at that and say, okay, so I see that 5 different IPs belonging to the same block /24 or block of 256 IPs have been limited. I'm going to assume that someone's using this range of IPs to collect data. I'm just going to block the entire range. And then that means you have a larger number of IPs being blocked for some time. And that can be very harmful for data collection operation. Although it's also important to say that when you allocate IPs through Luminati, I'm talking here about the data center and static residential, then we already shuffle the IPs in a way that even if some of them are blocked, there is pretty much 0 chances that you have more than just a handful of IPs coming from the same range. And in order to smartly manage your IPs and not reach these rate limits, then there's a few things you want to do. You want to keep the appropriate pool size. So you can see the screenshot here on the right, and the pool size here is 1500, just as an example. And in many cases, you won't know what's the right pool size when you start. So probably the best idea is to start with some random number that sounds a bit over what you need. And then you can start deducting or reducing IPs from your pool. And once you start reaching blockings or rate limitations, this is pretty much the line you want to avoid. Add some IPs, and then you're in the right place. And other than having enough IPs, you also want to make sure that you're managing them properly. So rotating them. It's not enough to have 1500 IPs if I'm using just 10 IPs out of them, and then I'm probably going to get blocked pretty quickly. So you want to make sure that you manage that. So this is all about the infrastructure part. Just one note I want to add here is that Luminati added about, I think it's already 6 months now, a very cool system called 100% uptime. And just a few words on that. So we've become very, very good in managing everything which is in our reach. We have thousands of servers and 9 petabytes going through our system on a monthly basis, a lot of traffic and so on, and we monitor everything and we know how to fix things very, very quickly. But sometimes things happen that are outside of our reach. For example, some tier 1 backbone carrier like CentralLink or Level 3 is going to have a cable cut or some outage or something of that sort, and then there'll be internet connectivity problems for many of their users. Maybe also Luminati, and we don't want. And now this is outside of our reach. We can only report it, and they're going to fix it anyway, and that takes time. So in order to avoid that interfering with our customers' work, we've applied a very smart system of fallbacks. And then whenever an IP is not working for connectivity reasons, then we're just going to route your request through a different IP, which is working fine. So this is activated by default for everyone, but you can disable it through your zone if you want to, but just so that this is already working for free for everyone. No need to make any changes. This is just working in the background.
Now, Aviv, if I could just take you back 1 second, we have another question by an anonymous attendee. If we enable IP rotation, when are they rotated? That's the question.
the way it works today in the Proxy Manager is that they're going to rotate every single request. You can define a pool size, like you see in the screenshot, and then it'll rotate between these IPs. In most cases, it's just going to be, if it's static IPs, it's going to be your entire zone, your entire pool size. You can modify it if you want, make a smaller pool size. For residential IPs, it will just want to rotate every time you make a new request if you turn it on. So basically, to make it simple, it's going to rotate every request.
Okay, great, thank you.
Sure. Okay, so now let's talk a little bit about proxy management. We've discussed into depth what's going on behind, behind the scenes, the proxy infrastructure that you're going through, and what you need to notice. But now you actually need to be able to manage your proxy operation, your data collection operation, in a way where you have everything in one place, and you're able to effectively manage all these things and keep track, have stats, and so on. So this is where our proxy managers comes to place, and we've developed it a few years ago, and it's basically a open source software where you can manage multiple proxies. You can do it through our UI, which I'll show you, or through API. And basically, it gives you one entry point for managing all proxy operations. There's just many built-in amazing features and settings into the Proxy Manager. And I'll just note about that since we give service to so many companies collecting data, we've realized that we have good access to understanding all the pain points for companies collecting data. And then we were able to add different features which bring great value for all of our customers. And each time we find a new one, we'll add it and we'll notify customers. So there's basically pretty much anything you can think of in there. There's a rule-based proxy automation. I'll show you that a little bit soon. You also have real-time in-depth statistics, and that's great for debugging or for getting all kinds of insights. You can use the link down here in order to download the Proxy Manager. A quick word about the architecture. So you're the crawler, you're making requests, and rather than going directly to our super proxies, which are our load balancers, then when using the Proxy Manager, you're going to be going through that software. It's going to go through the different rules and presets and the settings that you've defined. And that's going to continue to our infrastructure, go through our networks, and get to the destination, get back with the data, and so on. So what I'm going to do now is I'm going to show you 4 very basic features in the Proxy Manager, just to get you a little bit familiar. There's much more to it, and when you go to the one-on-one sessions after this workshop, you can ask to see all of them and others in more depth. But let's just give you a little taste of how it works. So I want to minimize the slideshow, and I'm going to go to the Proxy Manager. What I want to do now is show you how I manage geolocation targeting. So when you just go to the Proxy Manager, this is what you see. I want to clear out the logs for now. And I have one port that I've opened. I can open as many as I want, but I'm going to go to this port, which is basically a group of rules. I'm going to go in here into targeting. Currently, it's targeting the United States. Before I actually change it, I want to show you that it works. So I'm going to go to this website. It's called loomtest.com/myp.json. And this is a website that we built. It's connected to MaxMind, which is one of these geolocation databases. I make a request. The website sees what IP is accessing it and returns information from MaxMind. What is the IP? What country? ASN? Different parameters of geolocation and so on. So currently, I'm just going to refresh it. I'm going through our residential network. So I have this IP. It's from the United States. And now I want to try and change the geolocation. So I'm going to write here, Germany. It's already saved. I'm going to go back to the browser. And now when I refresh, I'm basically making a new request and going through that port, which is now not set for US, but for Germany. So I should see a German IP. Okay, great, so it works. and it shows a German IP. It's a residential IP. You can see all the other parameters they're matching. It's Munich, Bavaria, and so on. So this is just about targeting. Now, the next thing I want to show you is rotating IPs, which someone here asked about earlier. So let me show you how that works. I'm going to go back into the port. This time I'm going to go into a tab called IP control. And I have here the rotate IPs. I want to turn it on. And what it means is that from now on, each request I make is going to get a different IP. This is probably one of the most popular features, very basic, but used by many, many customers. So if you'll notice, I have an IP now ending with 167. And I'm just going to refresh the page, and I should get a different IP address now. So I have one ending with 17. I'll rotate it again, 142. So each request is getting a different IP. Okay, now we're getting to the LPM rules, to the Proxy Manager rules, which is probably my favorite part of the Proxy Manager, and there's just endless amount of things you can do here. And what we're going to do here in this example is set a rule to retry. Here actually it's written 502, but this is outdated, and it needs to be 200, just because it's easier for me to present to you. So I'm going to basically create a situation where if I get a status code of 200 in the request I make, something is going to happen. In most cases, it's going to work in a way that if, for example, you get a 502 or any kind of status, meaning that you're blocked or not getting what you needed, then you can define a trigger and action that can handle that situation. So let's create a new rule. So in this case, I'm going to start with the trigger by status code. And I'm going to choose 200. Now I'm going to choose the action, and I want to retry with a new IP one time. So just to explain what I'm looking at right now, I have a trigger and an action, basically saying if I make a request and I get in the response status code 200, then I want to have an action, which is retry with a new IP one time. So let's give it a test shot. I want to make a test request to loomtest.com, that same URL I showed you earlier, and I should get a 200 response code, status code, and then that means a rule should be triggered. So I'll make a quick request here. And I can already see that I got a status code 200. I want to go back to the overview, and then over here, in the logs, I can see a little green arrow next to that request I made to Loomtest. I want to click on that arrow, and it's very, very easy to see here that what happened is that I got a status code 200. That was the trigger. And here's a description of the action, retry with new IP one time. So basically, I made 2 requests, and that's by the rules. So that's really, really cool to see. And you can see here the 2 requests and different parts of information about them. I'll show you one more type of rule. And in this case, this is relevant for customers that they need a certain type of data, but there are other types of data that they don't need and they don't want to get because it's basically costing them more money. So in this case, I'm going to define a rule saying I don't want to get the response of anything which is a media type of URL. What do I mean by that? So when I go through a browser, there is the main URL that I'm going to, but there's also different sub URLs fetching, images and media files and advertisements and analytics and so on. And I don't want any of them. I just want the text, for example, in order to save costs and only get the information that I need. So let me go back to rules. I'm going to delete that old rule that I defined and make a new one. So first, starting with the trigger, it's going to be by URL. And I'm going to define the types of URL. These are all the media types of URLs, images and so on. Now I need to define the action. So what action that I want here is null response. If any of these URL is what I get, then I want to return a null response. so that I don't get them and I'm not charged for them. Okay, so the rule is all set. Now to show you this one, I'm going to go back here to the browser, and I'm going to go to Instagram.com. And basically what I'm expecting now is to get a presentation that does not have any media types of URLs in it. Mainly for this demonstration, it means I don't want to see any pictures. Great, so the site is fully loaded. This is not a problem with loading the site or anything like that, but it's just a site without any images, that's all. And that's exactly what I defined in that rule. Now, just to show you what happens if I turn it off, now the rule is deleted. And that means I should now get all these media files that I excluded earlier. Mainly, it means I should see a picture. And here we are, we got the picture. So this is just another one of these really cool rules and options in the Proxy Manager. There's many, many more. There's basically an endless amount of rules you can generate from this. This is just the tip of the iceberg, and just to give you a little taste. And a few more words about the Proxy Manager. This is about scaling. So there's different options for scaling your operation. One would be scale the Proxy Manager vertically, and that means you need to add more CPUs. In order to handle that on our side for you, then we added cluster modes, and that means you can add as many CPUs as you need. Very easy, very simple. A second option is scale the Proxy Manager horizontally, and then that's something that you would need to do on your own. In that case, you would need to set up any number of servers that you need, and download and configure Proxy Manager to each and every one of them. And then you would also need to configure a load balancer to manage which requests go to which server and so on. And then what we've recently launched a few months ago is the Cloud Proxy Manager. And basically what that means is that you don't need to care about any of the things I just mentioned. We do everything in the background. We scale it. We add workers and CPUs and so on. You just need to use it. Very, very easy, very simple. So that's it. That's for the Proxy Manager. And that was my part. Thank you for listening. And if you have any questions, then I'll be happy to answer.
Okay, great. Thanks so much, Avi. There is one question. Can you hear me?
Yeah.
So just one question. Can you limit the number of processes or threads to be used by Luminati Proxy Manager?
Basically, it depends on what way you're working with the Proxy Manager, but you can manage a certain number of sessions. So if you want to have a certain number of, let's call it channels of gathering data, each one of them could use a different session ID. And then whenever you want to change the IP, you could change the session. But basically, as long as you keep these, certain number of sessions, then they'll be the only ones using the Proxy Manager.
Great. Thanks so much, Aviv. And now we're going to turn to Josh Vanderwillick, who's a product manager. And he's going to speak to us a little bit about how to overcome digital fingerprinting. Josh, the mic's yours.
Hi, everyone. Can you hear me okay?
Yeah, we can hear you fine. We just can't see you presenting. So
You sure?
maybe share your screen.
Yeah.
Thanks. Great.
Hi, everyone. I'm Josh. I'm a product manager and engineer at Luminati. Over the last couple of years, I've been working on building our unblocker proxy, as well as the new data collector platform that we've implemented. So I'm going to be talking about two digital fingerprinting in general and two solutions we have for you. So the first solution that we have, just to summarize, is the unblocker. It's a proxy that tries to fix your traffic in real time. You can attach it to your existing data collection applications, and it should just kind of grease the wheels and make everything run a little bit smoother. The second system is the data collector, where we take over completely and we manage the collection end to end, and you just have to receive the data. So the general principle when you're dealing with fingerprinting is that you need to align your application with the real world as much as possible. This means that when you're experiencing blocking, you don't just change things randomly. You don't experiment on extra header values or whatever just to see what happens. You measure the real world, you check what Chrome, let's say you're trying to imitate Chrome 84, you check what Chrome 84 is doing and you do that. You do exactly that. So this means that you don't add extra stuff if Chrome isn't adding it, and you don't not send stuff that Chrome is sending. And the reason for this is every time that you look different from the system that you're trying to imitate, it's a case where you can be detected and blocked by your target site. So as an example here, a common problem I see is developers are working on building some data collector or crawler or something, and they see in the Chrome DevTools this cache control no cache header. So they add that to their application. The problem is that a normal user browsing the internet doesn't send this header. It only shows up when you reload a page. If you're trying to imitate a situation where you are reloading the page, then go ahead, add this header. If you're not trying to imitate that situation, then you might actually be doing yourself more harm than good by adding this extra value. So you need to measure what the real world is doing and do that. The order that you send your headers in can matter quite a bit. When building the unblocker, we were actually amazed to find how deeply sensitive some of these target sites are. So if you send the right headers, but they're not in the same order as a real browser sends them, then that's a sign that you're not really the browser you're claiming to be, and you might get blocked. So on the left here, you can see that Chrome DevTools by default alphabetize everything nicely. And if you click on the View Source button, you'll see that the order that they get sent in is actually different. So you need to make sure to do what Chrome's doing. The protocols you use can matter. Most crawling applications that I see work on HTTP1 just because it's simple to implement and it looks like it's working, at least at first. Most websites, or I would say a big chunk of websites these days, support HTTP2, which is a protocol for streaming many requests over a single socket to save on bandwidth and to improve speed. So Chrome supports HTTP2, and if your site is using HTTP2, then they'll be speaking HTTP2 to each other. But if your application doesn't speak HTTP2 and the site is expecting it, and you're claiming to be Chrome, which does speak it, then it's a sign that you're not actually Chrome, and this can be used to block you. Once you do switch to HTTP2, the format of the headers changes quite a bit. So if you do need to use HTTP1 for any reason, make sure that you're checking what Chrome is sending in an HTTP1 scenario, not an HTTP2 scenario. On the left, you can see that all the headers have capitals, and on the right, you can see that they're all lowercase, and there are these kind of magic headers that have the colon in the front. One interesting thing about these special headers is that your programming language might not be telling you the truth either. Unblocker is developed in Node.js, and one of the issues we ran into was we wrote the headers down in the code in one order, and the Node.js standard library actually flipped them around before sending them out to the target site. So if you want to be very confident that you're doing the right thing, you should use a tool like Wireshark to actually inspect the traffic that your application is sending, just to make 100% sure that the traffic you're sending to the target site is actually what you intend and matches the situation you're trying to imitate. When your application connects to a website using HTTPS, your code and the site do a kind of handshake to decide on a secure connection. The way that your code does this handshake and the way that Chrome does this handshake are probably different. Specifically, Chrome is probably using a newer TLS version than you are, and Chrome is probably using different ciphers and probably using extensions to the TLS protocol that you're not using. This doesn't matter in all cases. It's a little bit finicky to implement this type of blocking at a target site level. Some sites do this, and it can be the difference between being blocked or not. So if you're being blocked and you can't figure out why, and it always works in a real browser and never works in your application, then the problem might be the TLS connection. Unfortunately, this one is a little bit hard to solve independently because working with crypto code is complicated. We've put the work into this in Unblocker, and we actually support basically fixing the TLS handshake of your application seamlessly. So we do support this. You can do it on your own, but it's a little bit complicated. So let's review a demo of this just to see how it works. This isn't a full fingerprinting site, it's just a demo, but it showcases a lot of the principles involved. So if I navigate to this site, botcheck.luminati.io, I'll see that the user agent seems right, the header value seems right. It's warning me that some of these headers aren't correct, or not necessarily correct. You have to use them correctly. The header case is right, the header order is right, the HTTP version is right. Basically everything's right because this is a real browser, so of course it would be right. And if I take this, whoops, if I take the same site and I go over to a terminal and we'll try it with curl botcheck.luminati.io, and I'll add -b so we can see the headers it's sending. Then you'll see that I immediately get a fail because I'm using a command line library. And if I check the headers that we're sending, it says host botcheck.luminati.io, user agent curl. So we're just declaring that we're curl, so obviously it doesn't identify us as a real browser. We can try to fix that by opening up the DevTools here and reloading the page. And you'll notice that the cache control header pops up in the tricky headers. I need to make sure that I'm using that one correctly. So I'll go down to the headers in this list here. We'll copy the header here, copy the user agent, and then I'll do this request again. I'll just add my own user agent to the request. So now I'm claiming to be Chrome. And I see a lot more fails. So if I check the header I'm sending, it says user agent is Chrome. So the user agent is right, but now the header values are wrong, and the case is wrong, and the TLS version is wrong, and the HTTP version is wrong. And the reason is that curl isn't doing things at all like a real browser is doing them. So maybe we can fix it by copying all of the headers. So let's copy request, copy as curl. Clear this. So now we're doing the whole request like a real browser is, or we're doing the whole request with all the same headers as a real browser. And if I scroll down here, it says it's a user agent as a pass, but I'm still getting all kinds of failures. And in this case, the reason is the site is expecting me to be using HTTP2. I'm not using HTTP2 because it's curl, and all of the header values are wrong because the protocol version is mismatched. You can fix this in curl. You can set the right HTTP version. You can try to install the right TLS libraries and make sure that everything is correct, but it's kind of a rabbit hole to go down. You can start to check everything else off, but really your best bet is to use something automated. So if I take this example URL, let's run a demo through unblocker. I'll just paste it here. I'm using the unblocker zone, copy, and so in this case, you can see that, hold on. The settings seem to have screwed up since I ran this demo. Gotta turn off the company VPN. So now if I run this command and I just use a proxy, I don't add any extra headers, I don't do any sort of extra management, it automatically selects the correct user agent, matches all of the headers to the user agent, selects the right HTTP version, selects the right TLS version, and everything looks correct. This is kind of passively managed for you under the hood. So Unblocker has a bunch of automatic features for you. We'll pick the IP for you. You don't have to manage this. You don't have to worry about residential IPs and data center IPs and mobile IPs and rotation. We'll do it for you. We'll pick the user agent that makes sense. We'll match all the other headers to the user agent. We will upgrade your HTTP version and your TLS version for you automatically. If we detect the page is blocked, like let's say you get a 500 or a 404 or whatever status code, then Unblocker will seamlessly retry the request under the hood so that your code doesn't have to manage this. This system should be like a drop-in replacement for your existing proxy, and it should just kind of automatically help things work a little bit more smoothly. There are some cases where the fingerprinting gets a little bit deeper than what we've discussed. So when there's a full browser involved, there's a lot of moving parts. There's a lot of technologies working together, which means that there's a lot more opportunity for your code to get something wrong. There's a lot more stuff for the target site to look at to determine that you're not actually who you say you are. A real browser, when you navigate to a particular page and they redirect you somewhere else, if it's still on the same site, a real browser will reuse the existing connection to make the new request. Naive crawling code can open a new connection to make the new request, and this can be a sign that you're not actually a real browser. The way that you interact with the page can be used to fingerprint you. Let's take a Puppeteer example. If you're doing a search for a product on, say, Amazon, automated crawling code will usually do something like loading the page, immediately clicking on the search box as soon as the page is visible, typing the search query way faster than any user really could. As soon as they're done typing, immediately clicking search or hitting enter, and then jumping down the search results directly to the link that they want. This doesn't line up at all with what a real user does. A real user will load the page, they'll kind of move their mouse over to the search box, they'll click on the search box, they'll type and they'll make mistakes and they'll hit backspace and then they'll move their mouse over to the search button, or maybe they'll press enter after a couple milliseconds. So if you run an experiment in your system and it's always working when you do it manually and never working when you do it automatically, then you should try an experiment where you have your system run the automated stuff up to the point where you think you're being blocked, then take over with the mouse and keyboard and do it manually, and then let the automated system resume afterwards. And if this is working, then your problem is probably user interaction fingerprinting. Sometimes target sites will deliberately violate the web protocols just to see how your application behaves. So there's a spec out there for how the web is supposed to behave, and that doesn't always exactly match what Chrome and the other browsers do in reality. So in this case, you have a site that's deliberately sending an invalid character in a cookie, and Chrome replaces this invalid character with 4 spaces and just carries on. Node.js by default, for example, will refuse to process this request because it's not a valid value. If you turn this off and enable legacy HTTP parsing, then Node.js will replace this with 1 space by default instead of 4. So using this tiny trick, the site can tell that you're not actually Chrome because you're not handling weird situations in the same way that Chrome would. Some sites will use local storage as a kind of a super sticky session identifier that they can use to track you even if you switch out your IP and clear your cookies. Basically, whenever your logical session is done, whenever you're done with one kind of fake real user and you're ready to move on to the next fake real user, you need to make sure that you're completely clearing your browser, including local storage. I think Puppeteer by default does this whenever you launch a new browser instance. WebRTC is used by browsers to talk directly to other browsers. For example, video conferencing applications or file sharing applications will use this technology. It operates over UDP, which is not proxied by default. What this means is that if someone is trying to measure your real IP behind the proxy, they can connect to the browser using UDP, which will skip the proxy, and then they can tell what the origin IP address really is. The naive answer to this problem is to just disable WebRTC. The problem is that we need to align everything to the real world. And in the real world, users don't have WebRTC disabled. So this means that you need to find a way to make sure that your WebRTC traffic, if this is what's blocking you, is being routed through the proxy. Canvas fingerprinting is an extremely common technique. Basically, sites will draw a picture on your computer using some code, and the specific picture that results from this code depends on which operating system you're running, which hardware you're running, graphics card, etc., which browser version you're using, which fonts you have installed. So this is another way to kind of create a really sticky fingerprint that's hard to change unless you actually change the computer or the browser that you're using. You can experiment with trying to add noise or something to canvases to see if you can throw off the fingerprinting in this case. I think maybe Firefox does some anti-fingerprinting practices along these lines by default. But basically, if your code is working always on one computer but not on a different computer, this might be the technique that's being used to fingerprint you. The window size that you use while browsing is surprisingly important. I think Puppeteer by default will launch a browser with something like an 800 by 600 window. And this isn't an invalid way to browse the internet, but most users are browsing the internet using like a Chrome window full screen on a laptop or full screen on a desktop or maybe half screen on a desktop. And these sizes don't line up to 600 by 800. A laptop will be 1366 by 10 or 768, and a desktop will be 1920 by 1080. So it's not that using 800 by 600 window is invalid. It's just something that is odd about your browser. And if you have multiple things about your crawler that are odd, then the group of all the odd things together can kind of be a meta fingerprint that can be used to identify your traffic against, you know, the real world. Because if your traffic, like let's say that you're using 800 by 600 and only 2% of users are doing this already excludes you from 98% of the rest of the traffic that they know about. And if you're doing one other odd thing, then this brings the confidence that it's you down to like, now you're different from 99.98% of the rest of the traffic on the internet. So everything you do needs to line up to the real world, and most users don't browse the internet on a 600 by 800 window.
Okay, great. Thanks, Josh. Now, we do actually have a question from Joe Harrison, and his question is Puppeteer the best tool to use to mimic real users?
It's a matter of how much you need, because the best tool to mimic real users is real users. Everything that you do in an automated way is trying to live up to that standard, and you're always going to be failing in some way because it's not a real user. Some sites, no problem with Puppeteer. There are subtle differences in how Puppeteer sends headers, and especially if you're running in headless mode, there are subtle fingerprint differences. These are all fixable, but it's not maybe the best default. It is the easiest to use. It really depends on your organizational needs. If you have the resources to seriously invest in some fingerprinting, anti-fingerprinting technology, then maybe you can use Puppeteer and try to patch all of the differences. Maybe you can invest in Selenium. I'm not an expert on how Selenium's fingerprint looks, but there's always going to be a gap. It's a matter of minimizing the gap and checking which parts of the gap matter in your application.
Okay, great. And then just one more question from JS. What about sites protected with Cloudflare or Perimeter X?
So Cloudflare and Perimeter X are examples of what we've been talking about so far. They send some script to your browser. The script pokes around and measures your browser in a whole bunch of different ways. And then it sends some result home, basically declaring what it found. And then it's up to them to decide whether they think you're real or not. So obviously they can't be blocking real users. That's bad for business. And if your application looks like real users, it should be fine. Really, this starts to be a problem when your application is doing something that's obviously wrong. The canvas fingerprinting is actually a big one here. Did that answer the question or no?
Yeah, I think that's a great answer. Now, thanks so much, Josh. We appreciate your time and your explanation. And we're going to move on over to Gal El-Al, who's head of support. And he's going to speak to us a little bit about how to streamline your data collection. Gal, the microphone is yours. Please take control of the presentation.
Thank you very much, Nadav. Okay, so now we will talk about the data collector tool. Both Josh and Aviv showed you a lot of steps that require to do in order to collect the data, how to begin, how to identify each site and understand the site behavior and which tool to use. And eventually we've decided that we need a tool that can help you basically control all your data collecting need. without any code development from your side. So what is the data collector? It's basically an automated and customized tool. You can build your own crawler from the dashboard. We are now working on extension to even make it easier. So you just do the journey on your own one time with the extension. We basically collect all the information and provide you back the data in each required time. So the data collector can handle almost any kind of marketing need. If we're talking about marketing position, security enforcement, competitive intelligence, and market inventory. Of course, that we are using the most advanced technique in the TLS handshake to make sure that you're getting the proper response and the valid information that you require. And how does it work? What is the process? So you have a one quick start, one entry point that you come and build the collector, or even initiate a request to one of the support member or one of the sales team managers that you need a specific site, let's say in a daily basis or a weekly basis. And we create this custom collector and template for you. Then you tell us how often you need it. You can modify it by the control panel, which we will see in a quick example now. And you choose also the delivery method. The delivery method can be either a remote server that you need, a webhook, or even an email if you want to get updates all the time about the current prices on the market, or regarding your business. You can even check the information from your own phone by email. And of course, that it's a responsive tool. It means that every time that the site is changing, we have a metric that monitors the changes. We apply specific rules to each target site in order to overcome the blocking and provide you with real-time information. So let's see a quick trial of the data collector tool. I'll show you an example of how we're using it. And for this example, I actually chose a specific site in Canada, the site called Snuggle Bags. And let's open the site before I'm starting with the data collector. Let's see how the site is look when I open it from my real browser and what is the information that I want to get. So in this case, assuming I'm a retail company, I want to get the prices of and the title of each product in the Snuggle Bags website, and assume that I need it on a daily basis. I will go to the collector and we'll edit it. So of course, that's behind the template sits a code that we build, and we actually check the site fingerprinting and what is required in order to overcome it. Now we can choose the delivery method. As we said, we have the format, it's either JSON or CSV. If it requires, we can also provide HTML, but usually it's not necessary. The delivery method of email, webhook, Amazon, or SFTP servers. And we can also get notification by another method. For example, if I want to run with the first process, I get the prices, and I want a webhook to basically update the prices on my website, or either initiate another trigger. So we can control this as well. And for the last part, we have the schedule and the repeat interval. So let's say I want this once a week. I can automatically set it. I can also control all those features in API methods, and also control the request itself in API. So it's make it very convenient and very friendly, user-friendly. Now let's see the test of the collector itself. So everything that required for me here is basically the code behind the scene that we built for you. As you can see, it's a very simple code because our R&D team always make sure to build the right function for us, so we can easily build each collector and fast. Today, the market is very dynamic, and it's required for us to build everything very quickly. So let's click the example. Second. Good. And we trigger the collector. We can see that it's start to run. We can see how many items it will choose from the website and how many we actually get in the end. We can actually see the success rate if we have a successful request or errors. And of course, that the UI is always available for us, which make it very easy for us to use and to understand what's going on. So now we finished to basically load the page and we are starting to get the items. For my request, I actually asked to get the URL of each item because I want to check the real prices. I asked to get the title of the page and I asked to get the price itself. As Omri mentioned in the beginning of the lecture, of the webinar, I'm sorry, you can also get reviews. You can also get available items on stock. It's all depend on your requirements. And of course that you don't want to get a lot of data. You want only the data that's required for your business. And we are about to get done. Okay. Okay, so let's test the first product that I got. Let's just make sure that it's real correct product. And I see that I got the Omni 360 cool air mesh baby carrier with a price of $233. And let's verify this result. It's exactly the same. Of course, that it's changed from the color of the product or stuff like that, so we can see different prices. Any questions?
Okay, great. Thank you so much, Gal. At this point, we don't see any questions. And we're going to move on to the next portion. So as I mentioned at the beginning, if you guys are interested in a one-on-one session, we're actually sharing the links live to our data experts. And you can schedule a meeting with them. If you guys don't want to do that right now, we're going to send these links in a follow-up email. So please feel free to get your data collection project started as soon as you would like. Also, feel free to sign up for Luminati and start using all the products you saw in this webinar today. We're giving you guys a $100 bonus. You can use this link, which we're sharing now, and we're also going to send in the follow-up email so you can get started with one of our networks or products. You can also download the presentation using this link, which we're sharing now, and we'll also send in the email. Like we mentioned in the chat, we're going to also send you guys a recording of this webinar. Also, feel free to follow us on Twitter, on LinkedIn, on Facebook, on Reddit. We have a lot of very interesting information regarding not just retail, but data collection in general. So feel free to look out for those posts. And I just want to thank everyone, all our participants, all our panelists for joining us today. And have a great day. All the best.